Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Today I will talk about fundamental of logic. That is about connective and the law of logic. Next slide. This is our group member. Me, Muhammad Rafiuddin bin Abdul Hamid. Next to me is Muhammad Abra bin Ahmed Munir. And the last member is Muhammad Haris bin Muhammad Noor. Okay, for introduction, the law of logic is something that we can refer as a prepositional or a first order predicate logic. That from this referring, we can say that it is a collection of truth value true or a truth value false. For example, man is mortal, where we can say that it's a true value is true. Where if we say that 12 plus 9 equals to 3 minus 2, then we can say that the truth value is false. And the law of logic consists of variable and connective, such as and, or, implies, and negation, and etc. And for the law of logic, it also contains law of thought and rule of inference. Alright, for the connective, we have around 5. That is or, where this symbol looks like V, and that symbol that looks like an A, negation or not, implication, if and then, there is that symbol that looks like an arrow, and biconditional, that's the symbol that have 2 arrows. Next, I will pass on to Haris.
So this is a truth table for logic equation. There's all operation which when either A or B is true, the result will be A or B is true. But if both of them is false, so it will be a false statement. So there's also an operation. When A and B is true, the statement will be true. But if either one of them is false, so the statement will be false. And there's also implication operation. So if A is true and B is true, so the implication will be true. If A is true but B is false, so the implication will be false. If A is false and B is true, the implication will be true. And if both of the statement, if A is false, then B will be false, so the statement is true. There's also negation operation. If A is true, the negation will be false, and if A is false, the negation will be a true statement. And the last one is biconditional operation. So if A is true and B is true, so both of them is true. If A is true, B is false, so the biconditional will be false. If A is false and B is true, so the conditional will be false. But if both are false, the statement will be a true statement.
Okay, we will start with the question 1. The question is about write a symbolic notation and determine whether it is a tautology. The statement is, if I study, then I will get an A. If I will not get an A, therefore I did not study. For this statement, I let A as I study and let B as I will get an A. And the argument is A implies B and negation B implies negation A. Where I use the truth table for this argument. And from the truth table, I put A 0011 and B 0101. Where A implies B, I get 1101, and not B, I got 1010. Where A implies B and not B, I got 1000. When not A, I got 1100, and lastly, I get all 1. Where it is where the argument is valid and it is called as a tautology.
Okay, thank you, Muhammad Rafi. Today I want to present about the law of logic. First is the law of double negation. To change the not to the positive. Second is the not De Morgan law. As you can see, this equation. And the third law is a commutative law. This. And number 4 law is a associate law. This. The law of number 5 is the distributive law. This one. And number 6 is a idempotent law. Same to the P. And number 7 is identity law. Number 8 is a inverse law. This. Number 9, domination law. Number 10 is absorption law. And number 11 is application law. P plus Q and you get not P. And question 2, simplify this statement. As you can see, first we use the De Morgan law. We get this. And second, we use the law of double negation to change this negative to the positive. Then we use a distributive law. And we get this. We change to this, use a inverse law. And lastly, we use a identity law. We change this to the P. Lastly, we get P. Okay. So we pass this to the Haris.
So for the question 3, you can see a compound statement which have a 3 primitive statement, which is P, Q, and R. In this statement, we have 4 occurrence, 3 negation symbols, and 3 connectives, which is OR, AND, and OR. So from this compound statement, we can see that we can deduce it using De Morgan's law of double negation, associative law of AND, commutative law of AND, associative law of AND, and also assertion law. So what we can see from here, consequently, from the earlier statement, a weak compound statement is logically equivalent to a simple statement Q and R. So that's the reason why we are using logic law to simplify a compound statement. That's all from me. Thank you.